Hi everyone, in today's lesson we're going to review how to factor trinomials. So before we can do that, I want to actually recall multiplying binomials. So here we have two binomials together, and to multiply them we're going to use distributing. So x times x gives you x squared, x times 2 gives me 2x, 15 times x gives me 15x, and 15 times 2 gives me 30. So by combining my like terms, I get x squared plus 17x plus 30. So what conclusions can we make about multiplying these binomials together? First, multiplying two binomials will always result in an expression that has these three terms, which we call a trinomial. Okay, so a trinomial is always going to be the result of two binomials being multiplied together. If you multiply the first together, so where are the first? Here's the first of this parenthesis with the first of this parenthesis. If you always multiply those two together, what did we get? We got the first term of the trinomial, right? So if you multiply the first together, you'll always get the first term of the trinomial. If we multiply the last terms together, 15 and 2, we got 30. And what happened there? When I multiply the last together, you'll get the last term of the trinomial. And we like to call these guys the outers and the inners. So if you multiply the opposite color, so the x and the 2, that's the outers, and the 15 and the x, that's the inners. So we have the outers, right? And the inners, if we multiply the outers and the inners and then add them together, right? That's what we did here. We added them together. We'll get the middle term of the trinomial. So what we're going to work on today is, given this trinomial, can we work backwards to get this x plus 15 and x plus 2? All right, so now what I'd like to do is do the reverse. I'd like to factor trinomials with specifically a leading coefficient of 1. So what do I mean by leading coefficient of 1 is that the number in front of the x squared is in fact a 1, and the number in front of this x squared is a 1. So with all factoring, we have to remember to check for a GCF if that's possible. So let's look at this first example. I have 1x squared plus 17x and 30. I don't see a GCF other than 1, so we're going to go ahead and just factor this trinomial. So the way that I want to factor all trinomials is by using this AC method. So I don't know if you've heard of it or not, so I'm just going to write this down, the AC method. And this AC method is something that we're going to use when we factor all trinomials. So what it involves is we multiply the first term of the trinomial with the last term of the trinomial. So this AC is technically, this is your A term and this is your C term, right? Because all trinomials are in the form, or all quadratic trinomials are in the form ax squared plus bx plus c. If you vaguely remember that quadratic, right? This is your A term, your B term, and your C term. So that's why it got the name AC. So the name's really irrelevant, but that's kind of why it happened. So what we're going to do is we're going to multiply that first term by my last term, and we're going to put it as 30x squared, right? That's what we multiply. So we want to find the factors of 30x squared that add to this middle term of 17x. So first, let's find the factors of 30. So 1 and 30, we know 2 and 15, we know 3 and 10, and we know 5 and 6. But just be careful because we want to multiply to an x squared, so we need x and x. So we need 1x and 30x, 2x and 15x, 3x and 10x, and then 5x and 6x. So we want to look on this pairs of numbers and see which pair adds to 17x. So you should be seeing 2x and 15. So these two pairs, or this pair, adds to this 17x. So what we're going to do is we're going to replace 17x with 2x plus 15x. And then we're going to bring down all the other terms. We have the x squared and we have the 30. And you should remember from a couple of days ago that when I factor something with 4 terms, we're just going to factor by grouping. So we're going to group the first 2 terms, and we're going to group the second 2 terms, and bring down the sign in the middle. So my GCF of my first 2 terms is x, and I'm left with x plus 2. My GCF of my second 2 terms is 15, and I'm left with x plus 2. We should notice that this x plus 2 is in common, so that's my other GCF. So my final answer is x plus 2 is my GCF, followed by the x plus 15. And that is my final answer for factoring. Okay, let's try another one. So problem number 2, same concept. First, we're going to look for a GCF. So I noticed that there's no GCF, but what I'm going to do, like we did before, is we're going to multiply the first term and the last term. And by doing so, we'll get 6x squared. And we want to write the factors of 6x squared that will add to this negative 5x. So let's start with the factors of 6. So 1 and 6, and then 2 and 3. But don't forget, we have to multiply to x squared, so we need 1x and 6x, and 2x and 3x. Now, what we want to notice or find is the pairs that add to a negative 5. But on this list, this is only going to add to a 7x, and this is going to add to a 5x. But I want it to add to a negative 5x. So we have to think, well, I want factors of positive 6x squared. So couldn't I also have a negative 2x and a negative 3x? And a negative 1x and a negative 6x, right? Because a negative times a negative also multiplies to a positive. So by doing that, we find our pair. We have this pair right here, the negative 2x and the negative 3x, that in fact adds to this positive 5x. So we're going to go ahead and replace this negative 5x in the middle with what it's equal to. Negative 2x minus 3x. We bring down the first term, and we bring down the last, and then we factor by grouping, just like before. So we're going to group the first 2 terms, group the second 2 terms, and bring down the sign in the middle. So my GCF of my first 2 terms is x, and I'm left with x minus 2. My GCF of my second 2 terms is a negative 3, and I'm left with x minus 2. And then my GCF of these last 2 terms are x minus 2. So I'm left with x minus 2 and then an x minus 3. And that is my final answer. Just a couple of things I noticed about this one. Be careful when you're doing a positive 6 divided by this negative 3, you should get this negative 2. So don't forget that. All right, let's try the next couple examples. All right, I'd actually like you guys to try number 3 entirely on your own and then hit resume when you're ready for the answer. Okay, so you should have multiplied the first term and the last term together and got negative 40 x squared. And I want the factors of negative 40 x squared that are going to add to this negative 3. So your factors should have been 1 and negative 40, 2 and negative 20, 4 and negative 10, 5 and negative 8. And don't forget you need the x's for each. So I want to see which pair on this list adds to a negative 3. So the only pair that I think that would make most sense would be this one, 5 and then plus negative 8. So that's it. If you happen to have gotten, say you had this added to, like, say, a positive 3, all you would have to do is just switch the signs and you'd get the pair that works. So we're going to rewrite those signs in the middle. So 5x minus 8x is negative 3x. Bring down my first term and bring down my last term, and then factor by grouping. So I'm going to group the first 2 with the second 2 and bring down the sign in the middle. My GCF of the first 2 is x, and I'm left with x plus 5. My GCF of the second 2 is negative 8, and I'm left with x plus 5. Remember that a negative divided by a negative gives me that positive. The x plus 5 is my common factor, and I'm left with x minus 8. And that's it. That is my final answer. Okay, so number 4. Number 4 is a little different than all the rest because there's actually a GCF that I can pull out of all 3 terms first. So I can divide everything by 2, right? They're all even numbers. So when I divide 2x squared by 2, we get x squared. When I divide negative 42 by 2, I get negative 21x. And when I divide negative 200 by 2, I get 100. So at this point, we now can factor this inside trinomial using the AC method. So take a minute and factor this inside using that method we just learned, and then finalize your answer. And then when you're ready, hit resume for the explanation. Okay, so what we're going to do is when we multiply the x squared times the negative 100, I get that they multiply to negative 100x squared. And I now want the factors that add to this negative 21. So if I write down my factors, I have 1x and negative 100x. I have 2x and 50x, 4x and 25x, 5x and 20x, and then 10x and 10x. And you can go ahead and make one side positive, the other side negative. And again, if we don't find that right pair, we'll just have to switch it. So let's see. I want it to add to a negative 21. So which pair on this list adds to a negative 21? So you should be thinking 4x and negative 25x. So I can go ahead and rewrite this middle as 4x minus 25x. I can bring down my first term, bring down my last term, and factor by grouping. Group the first two and group the second two. My GCF of the first two is x, and I'm left with x plus 4. My GCF of the second two is negative 25, and I'm left with x plus 4. Remember that a negative divided by a negative is a positive. My GCF here now is x plus 4, so I can go ahead and take out the x plus 4, followed by the open parenthesis, and I'm left with x plus 25. And then the last thing is don't forget to bring down this GCF of 2, and that's my final answer. Okay, so now I'd like to do some problems where I have a leading coefficient that's greater than 1. So what do I mean by a leading coefficient greater than 1? So the number in front here happens to be a 2, not a 1. The number in this one happens to be a 6 and not a 1. So don't worry, it's still the same type of factoring. We're just going to always check for that GCF first. So with this first problem, I actually don't see a GCF other than 1. So we're going to go straight to that AC method. So we're going to multiply the first term and the last term. That gives me negative 54x squared. And then we're going to make the list of all the factors that multiply to negative 54x squared. Now, 54 is a number that might be too large to do without the calculator, or at least to find the factors. So there's a trick. If you go into the y equals and you type in that number, just 54, you can't put the x squared in. So just do 54 divided by x. It's a little trick. And you can hit the table of values. So you hit second graph to get the table. And that will give us the list of all the factors. So go ahead, type this into the y equals of your calculator and go to the graph and see what you get. So you should be getting 1 and 54, 2 and 27, 3 and 18, 6 and 9. Now you have to put in the x's, right? Because x times x is x squared, right? So you'll put those in, but at least that will give you all of the factors. And since we're multiplying to a negative 54, we actually have to remember to make one of them negative. So it's depending on how your calculator had it. I believe the right side was all the negatives, so you go ahead and put those. But remember, you could flip-flop them if need be. So we're looking on this list to find the pair that adds to this negative 3x, right? So if we look, I believe it's this pair right here. It's the 6x and the negative 9x. And if you add those, that gives you negative 3. So we can go ahead and put in 6x minus 9x for 3x, bring down my first term, and bring down my last term. And then we're going to factor by grouping. So we're going to group the first two and group the second two and bring down the minus sign. So we're going to take out a GCF of 2x and we'll be left with x plus 3. Second two terms, we're going to take a GCF out of 9 and we'll be left with x plus 3. And then the x plus 3 is what's in common. And then I'll bring down my 2x minus 9. And that is my final answer. Awesome. All right, so what I'd like you to do now is look at number 2. I'd like you to factor it, but remember, you might have to check for a GCF first. So go ahead, pause the video, give it a shot, and then hit resume when you're ready for the explanation. Okay, so you should have noticed that I take out a GCF of all three terms to be a 2. And I'm left with 3x squared minus 11x minus 4. And then on this inside, I can factor by grouping, or excuse me, AC. I have this 3 and this negative 4. I multiply them together, I get negative 12x squared. So the factors of negative 12x squared are 1x and negative 12x. We have 2x and negative 6x, 3x and negative 4x. And obviously we could flip-flop them if we need to. But I think we don't have to because the pair that adds to this 11 or negative 11x is right here, 1x and negative 12x. So I can go ahead and put that in the middle. So I have 1x minus 12x, bring down my last term and bring down my first term, and factor by grouping. Group the first two, group the second two. So my GCF is x, and I'm left with 3x plus 1. Here my GCF is negative 4. And I'm left with 3x plus 1. So I have 3x plus 1 and x minus 4 as my final factors. Just don't forget to bring out this GCF of 2, and that is your final answer. All right, awesome. I'd like you to try 3 and 4 on your own, and then we will go over those tomorrow in class. All right, have a great night.